Hello grade 12s, welcome back to the channel Science Therapy, hosted by the one and only science therapist Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8 on electric circuits. So it says a battery with an internal resistance of 0.5 ohms and an unknown EMF is connected to 3 resistors, a high resistance voltmeter, and an ammeter of negligible resistance, as shown in the circuit diagram below. The resistance of the connecting wires must be ignored. Right, so we have our circuit diagram here. Then 8.1 says define the term EMF of a battery for only 2 marks. So let's quickly run to that. So we say EMF is the maximum energy provided by the battery per coulomb charge passing through it. Right. Then we have the reading when the voltmeter decreases by 1.5 volt when switch S is closed. 8.2 says give a reason why the voltmeter reading decreases for 2 marks. Then we simply say it's because the energy is converted to heat. So the energy in the battery is converted to heat in the battery due to the internal resistance. So the presence of that internal resistance converts that energy into heat so that the battery can be heated up and so that it can operate. Right. Okay, now we have 8.3. It says calculate the following when switch S is closed. 8.3.1, the reading on the ammeter for 3 marks. Now you will note that we have already discovered that the voltmeter decreases by 1.5 volt. Right. Now we refer to this decrease here as the lost volt. And what we know as the lost volt is what is known as the V internal, right? So if they say the reading on the voltmeter, remember here this was an open switch, meaning no current was flowing. So the EMF here, the voltage that was being detected was the EMF, because remember also EMF is the total potential difference when no current is flowing. But by the minute the switch is now closed and then current starts to flow through the circuit, then we no longer have EMF, we have terminal potential difference, and then some of the internal voltage will now be taken by the battery there. So this is V internally is equals to I multiplied by the R internal. Now the V internal we are given it's 1.5 is equals to the current, but then the R internal it's 0.5. Right. Then if we divide both sides by this 0.5, then our current that flows in the circuit is 3 amperes. Now for 3 marks we know that's formula, substitution into the formula and the correct answer with the correct SI unit. So let's indicate this is 8.3.1. Right. Now let's proceed to the next question. We now have 8.3.2 says calculate the total external resistance of the circuit. Now to calculate the external resistance, that's R externally is equals to the resistance of the parallel plus the resistance of the series. So now to calculate this, we would have to start by calculating the resistance of the parallel combination of resistors, which is we calculated by saying 1 over Rp is equals to 1 over R1 plus 1 over R2. Or if you prefer the product over sum formula, that's Rp is equals to R1 multiplied by R2 over R1 plus R2. Whatever formula that you prefer, it's all up to you as long as you know how to use it. Then I will just go with this one because it's much more straightforward. So it's R1 multiplied by R2 over R1 plus R2. Right. So the R1, we will take it as the 25 here. Note that by saying R1 times R2, I'm not simply mentioning this R1. So let's edit and say R2 multiplied by R3 so that it suits the question here. And then we are able to see what we are calculating actually. So I will say 25 multiplied by 15 over the 25 plus 15. So note that I'm only focused on these two resistors that are connected in parallel. Now all you have to do is grab your calculator, punch that into your calculator, and then the value that appears there, you must write it in decimal form, 9.375 ohms. But then to calculate the R external, remember, we have to take this RP and add it to this resistor here that is in series. Now we can tell that this one here is in series and this two here in parallel, right? So take the ones in parallel, add it to the one in series, and then what do we have? Punch that into your calculator. We have 13.375 ohms, right? And then just like that, you have your total external resistance of the circuit. Awesome. Then let's proceed to 8.3.3. Right, it says calculate the EMF of the battery. Now to calculate the EMF of the battery, we know the formula that goes E is equals to I and then R external plus the R internal. Now we've already calculated the current, it's 3. Then the R external, we just calculated it from the previous question. That was 13.375, and then the R internal we are given here, indicated by the small letter R, which is 0.5. Now all we have to do is grab umshinwe ibalo and then just simply punch this, and then as it appears, so we have 3 bracket 13.375 plus 0.5 and then close bracket, right? So this will give us 41.625 volts, right? So I'm not rounding off anything. So okay, nice. 3 marks again. Formula, substitution into the formula, and the correct answer with the correct SI unit. So always put that in mind. Okay, so we have 8.4 now. Says the learner makes the following statement: the current through resistor R3 is larger than the current through resistor R2. So it's saying the current that passes through R3 here with 15 ohms is larger than the current that passes through R2 with 25 ohms. Is this statement correct? Choose from yes or no. Explain the answer for 3 marks. Now choosing yes or no, that's a mark, and then having to explain will be 2 marks. Right, so how do we explain that one? Let's quickly see how we're going to explain that. So the answer to that is yes. And then we're going to say according to R is equals to V over I. We know that the current is inversely proportional to the resistance. We know the relationship between current and resistance is that they're inversely proportional. For a constant voltage, it is very important to always mention that that will be true if the voltage is kept constant. Now we know that a larger current will flow on the smaller resistor due to this relationship here. So the one with the smaller resistance will have a larger current, which makes our statement true, right? So our statement is correct. Okay, so 8.5 says the 4 ohm resistor is now removed from the circuit. How will this affect the EMF of the battery? Choose from increases, decreases, or remains the same. And our solution for that one is definitely remains the same, because the EMF of the battery is not affected by how many resistors are in the circuit, because this is just the maximum energy supply by the battery. So whether you choose to put in more resistors or less of the resistors, this does not affect the maximum supply. So when you buy a battery and then it reads 18 volt, that's to say that the maximum energy supplied can be 18 volt, right? Or the voltage that can be supplied by that particular battery is just 18 volts. It cannot be more than that. It cannot be less than that, right? So awesome. Now, with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.